Distance and midpoint formula. So now we're going to be finding the distance and the midpoint given coordinates. So for instance, I have the points A and B on this graph, and I want to find AB, which means I want to find the length from A to B. So the coordinates of point A are -1, -1, and the coordinates of point B are 3, 2. Now, one of the ways that you could find this is using the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. But to use the Pythagorean theorem, I need a right triangle. So I can use the length from A to B as a hypotenuse, and I can draw in a right triangle. So now I can just count the lengths of the legs. This has a length of 3, and this leg has a length of 4. C is the hypotenuse. Remember that this hypotenuse is always the side across from the right angle. So if I were to plug in this information into the Pythagorean theorem, I'd have 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16, and to finish this problem, I have to square root both sides, and I happen to find that c equals 5. Now, we're not always going to have a graph. And oftentimes there's not going to be whole numbers and it won't be a pretty nice number. So there's got to be another way we can do this to figure out the answers for the length between 2 points. So let's look at where this came from. So 3, this number right here, this leg, came from the distance from going up and down from B to A. So if we look at this, this is going in the direction of the y-axis. Well, if we look at our y numbers, we have a 2 and a -1. If I find the difference between those, and remember difference is a subtraction problem, 2 minus -1 happens to equal 3. For the other leg, for the 4, this is going in the direction of the x-axis. So it's the distance, or the difference, between points B and A. The x-axis portion of point B is 3, and A is -1. And 3 minus -1, if I were to find their difference, is 4. So really what we're doing to find the 2 legs of a triangle is we are subtracting the x coordinates and we are subtracting the y coordinates because we're trying to figure out how far away they are. And to find how far away something is, that is a difference problem. That is where this formula comes from. So this is the distance formula of finding the distance between 2 points. Now to explain this, the notation is has these little subnumbers. So a subnumber isn't something you do mathematically. It's not like an exponent. It's basically telling you where something came from. So the way that you say this is x sub 1, which is saying it's the x-axis from, or the x coordinate from point 1. Y sub 1 is the y coordinate from point 1, which means x sub 2 is the x coordinate from point 2, and y sub 2 is the y coordinate from point 2. So if you look at the distance formula, what you're doing is you are subtracting the 2 x coordinates, and then you're squaring them. So the subtracting of the x coordinates is figuring out how far away on the x-axis are the 2 points. That gets you one of the legs of the right triangle. Subtracting the y coordinates is telling you how far apart the points are in terms of the y-axis, and then you're squaring them. Now the reason it's a square root is just like with the Pythagorean theorem, the very last thing that you do is you square root it to get the distance between the 2 points, to get the hypotenuse. So let's plug in some numbers. So I'm going to declare that point A is 0.1 and B is 0.2. I'm going to tell you right now that if you happen to switch those, it really doesn't matter. It does not matter which one's 0.1 and which one is 0.2. If you subtract them and you get a negative, and I subtract them and I get a positive, and we square them, they're both going to be positive. So the order actually doesn't matter. So the x coordinates are a 3 and a -1. So I'm going to go -1 minus 3 and I'm going to square it. That's the x sub 2 minus x sub 1 squared. Traditionally, we've always, as mathematicians, said the second coordinate minus the first coordinate. Why? Who knows? There's probably a reason. I'll look it up. Plus, now I'm going to subtract the y coordinates. So here's our y's. This is our y coordinate 8 and 4. So I'm going to say 8 minus 4. I'm going to square it. And the last part is to square root, and this is going to get me the distance. Now, order of operations tells me to first find the answers in my parentheses. So I have the square root of -1 minus 3 is -4. So that's squared. 8 minus 4 is 4. So that's squared. And then -4 squared is 16. 4 squared is also 16. And 16 plus 16 is 32. So if I find the square root of 32 as a decimal, that is about 5.66. So I just rounded it to the nearest hundredths. So that is one problem on how to find the distance between 2 points. Now we're going to find the midpoint. So this is if we're given 2 points on a coordinate plane, and I wanted to find the point that is exactly in between those 2 points. So if you're given 2 points, this again is our x sub 1, y sub 1. Those sub numbers refer to their point, like point 1 of the x coordinate of the point 1 and y coordinate of point 1. And point 2, x coordinate of point 2, comma, y coordinate of point 2. What you do is like you're averaging them, because finding the average is finding the number in between. So you average the x values by adding the x's together and dividing it by 2. And then you average the y values. So you add the y's together and divide by 2. The x average is the x coordinate of the midpoint. M stands for midpoint. And the average of the y coordinates is the y coordinate of the midpoint. So let's just say I was given the point 4, 10 and -6, 0. And I wanted to find the point that is in between those two exactly in the middle. So for the midpoint, what I'm going to do is I'm going to add the x's, so 4 plus -6 divided by 2, and 10 plus 0 divided by 2. So I have 4 plus -6, also known as 4 minus 6, which is -2, divided by 2, and 10 plus 0 is 10 divided by 2. And if I finish this to get a whole number, if it's not a whole number, leave it as a fraction, I get -1, 5. So the point -1, 5 is directly in between points A and B. Now sometimes you're given the midpoint and what you're missing is one of the original points. So if M is the midpoint of segment CD and I don't know what point C is, I know part of it. So if I were to start to write this, if this is point D, -3, -5, and C is some point X, Y, if I were to figure out the midpoint, I would have added -3 and x, divided it by 2. Then I would have added -5 and y and divided it by 2. So I basically just used these 2 points, one of them being unknown, but I know what the answer should be. My answer should be the midpoint. It should be 4, -9. So what I can do is say somehow when I take -3 and I add an unknown x coordinate and divide it by 2, my answer should be a 4. And if I take -5 and add it to the unknown y coordinate and divide it by 2, my answer should be -9. I now have 2 equations that I can solve. So if I multiply both sides by 2, I get -3 plus x equals 8. If I add 3 to both sides, x equals 11. And on the other one, if I multiply both sides by 2, I get -5 plus y equals -18. If I add 5 to both sides, I get y equals -13, which means that my missing coordinate that I originally did not know what it was is the point 11, -15. So between -11, -15 and -3, -5 is the point 4, -9.